Hello and good day everyone. Today we are going to present about CVP analysis for multi-product. First, the definition. Multi-product is where a company sells more than one product which has its own characteristic and sold at different prices.
Firstly, in order to calculate BEP for multi-product, we need to know sales mix. Sales mix is relative proportion of sales of each of an organization's multiple product. To calculate sales mix, volume of product divided by total volume. So, to calculate sales mix for free-range chicken, we can see here 50,400, which is the volume for free-range chicken in unit, divided by 120,000, which is the total volume for both product. So, we get 42% or 0.42. For organic chicken, we divided 69,600 by 120,000, so we get 58% or 0.58.
The next important terms are weighted average cost method. It is the average of a firm's several products' unit contribution margins weighted by the relative sales proportion of each product, which is known as sales mix. The formula for weighted average cost method calculation is contribution margin for product A times with sales mix product A, and then we plus with contribution margin product B times with sales mix product B, and plus with contribution margin product C times with sales mix product C, and then we can get the WSCM or weighted average cost method. For example, in this case we have two products, so we calculate the WSCM for free range chicken plus with WSCM organic chicken. As provided, there was a contribution margin and sales mix for each product. Then we calculate them according to formula provided, which is contribution margin times with sales mix. Then we can get the WSCM for the products is 6.85.
There are two ways to determine the break-even point for multi-product, which are by using formula and graphical technique. For by using formula, these are the formula that we're gonna use to determine the BEP in units and values. The first step, we need to calculate the contribution margin per unit, sales mix and WACM for each product. It is better to put all the information in a table because it will be easier for us to calculate. And then sum up the total volume in unit and WACM for all product, and we will get 6.85 for total WACM for both free-range chicken and organic chicken. After that, we can calculate our break-even point in unit by dividing the total fixed cost with WACM. The total fixed cost given in the question is 130,698 ringgit. So the answer will be 19080 chicken. It means that to break even, the company must sell the total of 19080 of free-range chicken and organic chicken. To find break-even point in value, we need to calculate the overall CS ratio first by dividing the total contribution with total sales, then multiple with 100. To calculate the total sales, we need to multiply the total volume in unit for each product with the selling price per unit. Then sum up all the answer and we will get the total sales of 1598400. Then to calculate the total variable cost, we need to multiply the total volume in unit for each product with the contribution margin per unit. Then sum up all the answer and we will get the total variable cost of 822000. For total contribution, we need to minus total sales with total variable cost and we will get 774400. Put the amount that we have calculated into the formula and we will get 48.5736% for the overall CS ratio. Then we can calculate our break-even point in value by dividing the total fixed cost with overall CS ratio, and the answer will be 269072 ringgit.
Next, we move to graphical technique. Based on the information, we identify the product ranking from the contribution margin ratio. The purpose of identifying this ranking is to find which product line to start with when drawing the multi-product profit volume chart. The product with the highest contribution margin ratio will start first. From the information, free-range chicken product has the highest ratio. The next step is to calculate the profit. It can be seen from the graph that the business will start making profit from the 19,080 chickens, and the margin of safety should be 111,618 units, reading off from the graph given.